Hello there. In this video I'm going to be reviewing a really useful and cool soldering iron, the KETS02 from Kaiweets. Now before I get started I must point out that they sent it to me free of charge for this review. And I'm glad they did because it changed my view of USB-C soldering irons. The ones I had previously had been dismal, but this has really changed my opinion. And if at the end of this video you feel that you want to buy one of these, check out the description because you'll find a couple of discount codes where you can get between 15 and 10% off. So if you look at the basic parameters, it's powered by Power Delivery USB-C or PD, and it's got a OE LED display 0.870 inch. Temperature range 80 to 420 degrees Celsius or 80 to 780 Fahrenheit. Voltage range between 9 and 20 volts. And this particular one comes with 6 pieces of soldering iron tips. Now the price you pay depends upon the package you get. If you just get the basic package with 1 tip and no power supply, I think you can get it from around 40 USD in that sort of range. But if you get the full package, it's more like 80 USD, which is what I've got here. But if you look in the comments, I'll provide you with a discount code where you can get 15% off. So the manual looks pretty well laid out. And if we look at this, you can see the different performance according to the voltage it uses. Of course, under PD, the voltage range is selectable or negotiated by the device and the capabilities of the power supply. You can see you've got 65 watts at 20, 37.5 watts at 15, 24 watts at 12 volts, and 13.5 at 9 volts. But the tin melting times are subjective. Obviously that depends on how much solder you're heating up and how big the thermal mass is. It looks like quite a comprehensive, easy to read manual. We'll go through all these function settings later, or parameters. You can see the firmware is upgradable. Got how things are moved on. Fancy you can change the firmware on your soldering iron. Multiple languages supported. What's that? German, French, Italian, is that Spanish, Japanese? Oh, that's good. So what we got in the box? So we've got our USB-C power supply, 65 watts of course to support the maximum power, and it's a GaN. What was GaN? I'm trying to remember. Oh yeah, gallium nitride. Goodness knows why you need that. Sounds like some sort of fertilizer or something. You can see on the power supply here, it supports all the currents at each voltage range to support the rated power output of the iron, as we just saw in the specs. Fortunately, they sent me the European plug and I live in Singapore and we use the British or UK system. Oh well. Well, tell you what, it feels nice and cool to the touch, which means it's got a metal body. That's good. It looks well built. Looks like I like this bit of silicon there, and it's got flats on it to stop it rolling around on the desk. And that metal cap is handy, so you can put it on when it's still hot and not worry about burning a hole through your tool bag. It feels very nice actually. What's going on there? That was a bit disappointing. I was expecting that screen protector to go the whole length of the screen. I've been shortchanged. Yeah, I'm liking it, but that display is very small. I guess this is where the tips and cable is. Charging cable. Well, not charging cable, power cable. It doesn't have batteries in it. It's not rechargeable. You have to have it plugged into a USB supply. Whoa, look at all these tips. Okay, so what we got here? Looks like we've got a beveled tip, the BC2, and a larger big brother beveled tip, BC3. Okay. And then we got a conical, B2. We got a needle for our ILS, that's great for SMD work. So we got a knife, KR, and the smaller one, the KR is at 6.5. Well, that's good. Good range of tips there for most. I'm sure that'll cover you for all your applications. Oh, this feels nice. Silicon. Oh, that's lovely. I wish you could feel this. And very, very flexible. That's not going to hinder your movement at all. That's very nice. And of course, it's USB-C. So that looks like quite a good power delivery cable. little soldering iron stand. Well, I'll get you out of trouble. If you haven't got one, stops you burning your friend's desk. But yeah, I must admit, that cable's better than expected. It's a bit thicker than I expected, but it's not so thick that it's restrictive. Let's see how one of these bits go in. You notice that they're lead 3 as well, that's good. Okay, so I'm going to put in BC3, which is the large beveled tip. So you've got like the connections there for heating and I guess thermo or temperature sensor. Note that these tips have a heater actually inside the tip itself. So every tip has its own heater. That's why these things can heat up so quickly and give good temperature control. Okay, so that's nice and firm. I like the balance. Let's see how it is when you've got a cable plugged into it. But it feels pretty good. Well, the stand works, but you're only going to use it on site or in emergencies. Now let's take a closer look at each of these tips. So this is the large beveled one, the BC3. Quite big. It's probably bigger than I would actually use on a day-to-day basis. And then you've got the B2, which is a small conical size. Too big for SMD work, I think, but for general work it's okay. And then we got the KR, which is a large knife. Now this one's got a lot of thermal mass on it. I think this would be good for removing large components. And then this one is another knife, but a smaller one, the smaller brother of the KR, the K65. It's probably a nice size for heating up both sides of an SMD resistor or capacitor when you're trying to get them off the board. That's quite useful. And then we've got the ILS or a needle type tip. Now this should be really good for SMD work. We'll try that later. And then we got the BC2, which is a beveled tip. Now this one is probably one I would use from day to day. I think the other beveled one is too big, but this one looks perfect. I think this would be my daily go-to for a tip. So there you have it. That's the 6 tips. Now let's have a look at the construction and ergonomics. So it's saying it's a nice, cool metal body, and the cover seems to be made out of the same material. And to secure it, you just slide it on and then turn it. Now that flat dot on the silicone bumper is really good. It stops it rolling around on your desk. It's very effective actually. But it feels like a really quality product. I like it, and it feels comfortable. Yeah. I think they've got that right. And I've got the cable plugged in as well, and the balance still feels good. Now let's have a look at the stand with it. Okay, so like I say, this is just an emergency, stop you getting caught out. But I thought what I would also do is see how it fits in my standard everyday stand that I've got on the bench. So this is it. It's the ST90. I really recommend it if you're looking for a stand. It's heavy, and it's got space for your brass wool cleaner or your sponge, whichever takes your fancy, and it's adjustable, and it fits really well. So I'm liking that. No problems. Okay, let's now have a look at the menu structure. What can you configure this thing? So when you first switch on, you see on this small display you've got a little flashing button on the left. So a quick tap of that powers it up. Now if you look at the information, you've got the target temperature or the set temperature, which is currently 320 degrees, and above that you've got the voltage it's operating at. Then you've got the actual temperature, and that little bar graph at the bottom is showing you what percentage of power used. And then to change the temperature, you just hit one of the buttons, one of the two buttons, and then you can increase or decrease. And yes, you can change this to Fahrenheit as well. I'll show you how to do that later. It heats up very quickly, thanks to the heater being in the tip. It's very responsive. Not sure how useful that little power bar graph is though. Now to go into the menu, you hit both buttons at once. If you've got big fingers, you can actually press both at once with your thumb, or big thumbs. So here the first thing is brightness. So as you get into a menu item, you long press the right button, and then you can then use the two buttons to make an adjustment to that configuration item. So that's brightness. And then we go on to calibrate. Now what calibrate's used for, if you've got a device to measure the temperature of the tip and you find that it's not quite accurate, you can use the calibrate function to make an adjustment. Like so. To exit out of the menu item, you just press the long press the right button again. So then we got temperature units. So for those of you in the States, you can use this to change to Fahrenheit. Let's just check that works. We'll quit out the menu by doing a long press on the left hand button. So now you can see we've got Fahrenheit for both the actual and target temperatures. So back into the menu again. I'm going to change that back to centigrade, or I'm going to get really confused. Okay, so back into the menu, selection items, we've got sleep time. So this is the amount of time the iron will wait to put the iron to sleep to its sleep temperature if it detects no use or movement. And you can switch that off as well, as you can see, or between 1 and 20 minutes. And then we got the sleep temperature. So you can kind of keep it in a standby temperature if it's not being used, so it heats up quickly. Currently set to 160. So you can set it that between 80 and 200. Then you've got the child lock. If you've got the child lock set, rather than a single tap to activate the iron, it takes 3 taps. And for those of you which are left-handed, you can use this function to rotate the display 180 degrees. So that's a nice thought. I accidentally went out of the menu. Let's go back in. Where were we? Sleep time, child lock, handheld. Important one, voltage selection. So as you saw in the manual, it can operate in one of 4 different voltage modes, 9, 12, 15 and 20. Each of them have a corresponding maximum power. So you can actually change the voltage. Now I'm not sure what the use case is here. We'll play with that a bit later. And then then we're back to brightness. So that's all of the menu items. And to switch off, you just hold down the button on the right. And there we go. So that's it. That's the menu system and device parameters. Right, so now I want to take a look at how the voltage selection menu item works. So I've got it connected to this DIY USB-C breakout box, and then measuring the voltage, so I've got the multimeter on the left. So I'm going to plug the iron straight into this breakout box, and then the input of that breakout box I plugged into the supply. So you can see that it's gone to 20 volts because it's a supply with a maximum of 20 volts, so it's selected the highest. But that's not necessarily the case, because we can change the maximum it selects using the voltage menu item. So I'll show you. So I'll go to voltage select. Okay, there we are. So I'll go in, and now I'm going to change it from 20 to 15. And if you can see, it's a bit out of focus on the multimeter on the left. It's dropped to 15. So it's renegotiated the supply voltage with the power supply. Now it's down to 12. Now it's gone down to 9. Now let's switch it back up again. Up to 12. Up to 15. Up to 20. I can't think of a use case where you want to reduce it. Let me know in the comments if you can think of something. Maybe if you plugged it into a supply and it's not negotiated the highest voltage, then you can use it to force it. I'm going to plug it in now to this power bank, and it's got 5 volts, 9 volts and 12 volt support. I want to see what happens if we plug it in and try and set it to 15 or 20 volts. Let's have a look. Because of course those two voltages are not supported by this power bank. So iron's powering up, and you can see it's gone straight to 12 volts, which is the highest voltage that this power bank can supply. Let's just go into the menu. Sorry about the focusing, but it just reset. I don't know if you saw that. It looks like the power bank is having problems in supporting the current being drawn. If there's a current overload, then the power bank switches off as a form of protection. Let's try that again. I'll switch it back. It's just reset again. I don't know if you noticed, but we can look at the manual later, but the power bank can actually support the required current on the 12 volt range. It can on the 9 volt range, but not the 12 volt range. Let's just see how that performs. See if it will. Now the iron's heated up, maybe it won't draw so much current anymore, and the power supply keep it running. Yeah, looks like it's a case. Alright, so let's change the temperature. Seems to be working okay. Let's go into the menu, go to voltage select, and let's see what happens. Okay, so we've still got the 4 options up to 20 volts. I guess what the way to read that is the maximum voltage it will try and negotiate. So now I've got it down to 9. You can see on the multimeter on the left it's switched to 9. Go back up to 12. You can see on the multimeter it's actually gone up to 12. It's got to 15. Yeah, and nothing's happened as you expect. And it's reset again. So this power bank is really struggling to supply this. So be warned. We'll have a look at the necessary current ratings for this iron again shortly. But if you're going to intending to use it for a power bank, you need to make sure it's got sufficient current supply. Right, I'm just going to switch it back on and then get a bit of solder and see how readily it melts it. Well, seems to be functioning okay, but the moment I cause the current to increase, I can imagine that it will just reset. Now let's have a look at the current requirements again, see what was going on here. So at 12 volts it can be equal or greater than 2 amps. That's why we got 24 watts of power. And then at 9 volts it's greater or equal than 1.5 amps, gives 13.5 watts. Now let's have a look at this power bank. Okay, so at 9 volts it's supplying 2 amps, but at 12 volts only 1.5. And that's why we were having problems. So be warned, we need to make sure that your power bank has got sufficient current to support it. Now, something weird I noticed, well I say weird, but I've seen this on my bench power supply as well, which also has individually heated bits. If you put in a new bit, like so, something very strange happens. I think it's a type of self-calibration process, but you'll see the temperature jumping all over the place, and then it stabilizes. I can't see anything in the manual about this, but like I say, I've seen it with my bench soldering iron as well. You look at this, can you see how the temperature's jumping around all over the place? Sometimes 200 and something, sometimes it's 400 and something. But eventually it settles down. It's almost like it's self-calibrating. If anybody knows what's going on here, let me know. I'll be interested to confirm what it's doing. Watch it, slowly but surely it's settling down around the target temperature at 320 degrees. There you are. But I find this happens every time you put a new bit in that hasn't been seen before. So, as I was saying, my T12 bench soldering iron does exactly the same thing. And it has a similar design where each of the bits has its own heater and temperature sensor. Now let's do a first test. Easy one first of all. Is at 360 degrees off a 20 volt power supply. And let's just see what it's like at tinning a relatively thick cable. We've got good heat flow. You can see that wire wicking up the solder easily. That's nice. No issues there. Not that we should expect it. Now let's start some torture tests. My first torture test. Now I haven't got a lot of hope for this, but I've got an old variable capacitor here, and a while ago I soldered a bench power supply, a wire onto it, and it was quite difficult because you can see it's being soldered basically to a big piece of metal which sucks away all the heat. And to make it more difficult, I'm going to power it with a USB power pack. This is one from Ugreen, 100 watts, and if you look at the specification, just find it down here somewhere. That's charging input. Output 20 volts at 3 amps. Sorry, 5 amps. 15 volts at 3 amps, 20 volts at 5 amps. That's where you get a 100 watt supply. So let's give that a go. It should be more than capable, of course. Make sure I plug it into the right one. Out 1, that's it. So, as I was saying, my bench soldering iron really struggled with this. So I'd be interested to see how this portable iron handles and off of a battery pack. So I've got the big knife bit. Plugged it in, you can see the voltage is 20 volts, standby current of 9 milliamps. So I'll switch it on. I saw the current there go up to around 2.9, 2.8. So that would be, what about, I'll call it 3, so that'd be about 60 watts. 3 times 20 volts. I'm going to set it to 420 degrees, the maximum temperature. This is the biggest bit I've got, the one with the most thermal mass. Let's see how we do. I'm expecting the current to go up. If you look on the display there on the multimeter on the left, you can see the current consumption. It's not going up as much as I expect. It's only about 1.3. That's only about 25 watts. I'm surprised about that. Why is it not consuming maximum current? Well, I guess it's using pulse width modulation, so the interpretation of the current consumption by that multimeter may not be very accurate. I can feel this getting warm already. That's a lot of metal to heat up. Oh, it's starting to melt. Can you believe it? Look at that. How long was that? Was that about 6 seconds? I'm amazed. I am very impressed with that. I never expected that. This actually performs just as well as my T12 bench iron. Well, that is a surprise. But I'm surprised not to see the current consumption go higher. But like I say, that might be a misreading. Let's see if we can apply some more solder. Yeah, it's melting quite well. Not flowing particularly well because it cools down so quickly, I guess. You get spikes on it, but brilliant, amazing. You can see the current going down now as the iron's not attempting to heat anything up. Looks like it's idling around 500 milliamps, or what's that, 10 watts. Let's see if we can put the wire back. A bit more solder on. Okay, it seems to be melting well, and binding with that wire. Okay, great. Bob's your uncle. Wow. Well done, Kaiweets. I never expected it to perform so well. Now for my next torture test, I'm going to use another part of this variable capacitor. You see the terminals which are connected to those static plates. Each of those plates is like a little heat sink. So there's a lot of thermal mass in there. And what I thought I'd do is I would use maybe 9 volts and 15 volts to see if I could still solder them. So if we look at the specifications on this again, we should be able to get 2 amps at 9 volts. And according to the spec of the meter at 9 volts, it only requires 1.5 amps. It was about 13 watts ish. So the power bank should be okay for that. Again, I'm using the large knife bit. Okay, so I will start it up. You see on the multimeter 12 volts is being supplied. Let's change that down to 9 volts because we know this power bank cannot supply the required current at 12 volts. Okay, so now we've got 9 volts, so we should be all good. Okay, so we get the target temperature 370. Okay. Let's give it a go. Oh, it's just reset. That's not good. But I know this power bank is very sensitive. It maybe just a short peak over 2 amps and it will reset. Let's try again. Oh, it's just reset again. It's not going to work. But you know, I don't think it's an issue with the iron. I think it's a problem with my power bank. I'm going to try using the bigger power bank and just set the voltage to 9 volts. See how we get on. Okay, let's try again. So you switch it on, you can see it's renegotiated 9 volts. It remembers the setting from last time even though it's powered off. That's good. So even though this is a 20 volt capable power bank, remember in the menu we've set it to the maximum negotiated voltage is 9. Okay, so well, the solder's melting, but you know what? It's not taking 1.5 amps. It's only taking an amp, which means we only got 9 watts, which I know would definitely not be enough for this. I wonder why that's not taking more current. Let's try that out to 420 degrees. Let's see as a target temperature, see what happens. So it should be consuming maximum current for its voltage range to get to the target temperature, but it's not. Well, it's not going to work at 9 volts, that's for sure. The iron's kind of sticking to the joint because it's just not hot enough. Let's change the voltage to 12 volts and see how we get on. Okay, you can see immediately the voltage on the multimeter has gone up to 12. Again, remember we got it set to 420 degrees. Still taking just under an amp. So now we've got what, 12 volts, 12 watts. Hopefully the current will go up as we're heating this joint. But no, not really. You see the current consumption is still 0.883, so that's only about 10 watts. Well, that's not as expected. It seems to take more current when it's first heating up to get the tip rapidly up to temperature, but once it's at temperature and the tip starts cooling because it's trying to heat something, it doesn't seem to draw the maximum current again. Have you got one of these and had a similar experience? Let me know. Let's take it up to 15. Okay, so now it's about 1.1 amps, so we should have 15 watts. Now that's working. That's working well, actually. And this is not an easy joint to melt. Yeah, that's going to work. It might be because of the pulse width modulation, the way the current is modulated, that this multimeter is not measuring accurately. So do bear that in mind. So that's good. No problems there. May as well do one more while I'm at it. This variable capacitor's actually got two. It's a 2-gang variable capacitor. May as well solder the other wire. It's for another project I'm doing. May as well do it now. A bit more solder. Oh yeah, this is no problem at all. Perfect. Well, I'm happy with that. Okay, so now I'm going to do a stress test at the opposite end of the spectrum. Well, actually, it's more of a stress test for me. I'm going to use the ILS or needle bit, and I'm going to use it to solder a 0.1mm wire onto one of those pins of the microprocessor on this Arduino Nano. So I'm going to remove this chunky knife bit. Now, I've not used this bit before, so I'm expecting the temperature to be all over the place until it settles, as I showed you before. And as expected, it's all over the place. The current target temperature is currently set to 420. That's too high for doing what I'm doing. I'll put it down later. But you can see it's jumping all over the place. It should eventually settle at 420. I'm going to change that down to make it more suitable. 360. Okay. So, first of all, I think we should get some flux on it. I hope you can see this alright. I can't be bothered to get my microscope out. Sorry about the focus. Okay, see how we get on. I expect that's going to be unleaded. It'll be difficult to work with, so I'm going to put a bit of leaded on there. And I guess let's have a go at putting the fine wire on the third pin. No particular reason. Okay, so that seems to have worked okay. Now, like I say, this is really a test for me. See how steady I can hold my hand. Oh god, this wire's thin. Okay. What is there? I think that should be it. Yes, success. Just check we haven't shorted adjacent pins out. Looks good to me. So, yeah, both ends of the spectrum are soldering. I think this is a very capable and useful tool. I like it. Now, in case there was a firmware release for this, I'll just show you how you put it into bootloader mode. So you hold down the left button as you're plugging in the power supply, and there you are, it goes into bootloader. And then of course you'd follow the appropriate instructions for the software release. Now, before I go to the conclusions, I want to tell you about some offers that Kaiweets have shared with us. The first one is a 15% discount if you buy direct from their store. Have a look in the description and you'll find a discount code which allows you to do this. Now, this discount code will never expire. Another code they're giving us is one for Amazon where you can get 10%, so it's not quite as much. And do note that it's also time limited, so check the description for more details. Now, it's been about 3 to 4 weeks since I made this review, and in the meantime I've been taking it to work and been using it a few times a week, and I've got to say it's been brilliant, and I wouldn't want it to be out of my toolkit now. I've really been impressed with its performance. The concerns we saw about the power being consumed when it's on a power bank operating at lower voltages, like you saw when it was at 9 volts and 12 volts, it wasn't drawing the quoted power in the specifications. But I found actually in practice when I was doing work on PCBs, etc., it wasn't a problem, and the iron managed to heat the joints up quickly and without any issue. One problem I did have when I was getting used to it was accidentally hitting either the button to switch it off or accidentally changing the temperature. I didn't notice the iron was rotating in my hand when I was soldering. But I got used to it in the end, and I don't find myself doing it anymore, so I think it's just a matter of getting used to it. So in summary, I think it's well built. Ergonomics are good, nice to hold. But like I say, you just need to make sure that you're holding it so you don't hit the buttons when you're using it. Bits are easy to change. I would recommend the essential bits, if you don't buy the 6-pack, is the large knife bit, that's the KR, because you've got good thermal mass for desoldering big parts. The ILS, which is good for surface mount. And then the small beveled bit, which is already in the iron. So that's the BC2. I think these 3 bits are the essentials you need. The others are optional, I would suggest. This little holder is okay, gets you out of trouble. And the supplied adapter has been good, no issues with it. Though make sure when you're ordering your iron, you get one with the right country for the adapter type. And then the cable's good, heat proof, slinky, doesn't restrict your movement. And I really like the cap. Even if the iron's hot, you can slip that on without worrying about the iron burning a hole for your tool bag when you finish with it. So yeah, I recommend it. If you found this video useful, please give me a like, or even better still, subscribe. And until next time, take care and look after yourselves. Bye for now.